Hello students, in this lecture we are going to study how to calculate focal length and power of lens to correct the defect of human eye. Fine. In this we have two types of numericals. First is the case of myopia and second is the case for hypermetropia. Fine. Now you need to remember 2 points to solve the numericals for focal length and power of lens for the defects of human eye. We know that the lens formula is 1 by V minus 1 upon U is equals to 1 upon F, where V is the image distance, U is object distance and F is focal length. Fine. You need to remember in the case of myopia, the value of U is minus infinity. Fine. And the value of V is equals to minus X, where X is the far point of myopic eye. I'm repeating again, X is the distance of far point of myopic eye. Fine. Now putting these values in this equation, we have 1 upon minus X minus 1 upon minus infinity is equals to 1 upon F. So 1 by infinity becomes 0. Fine. So it becomes minus 1 upon X is equals to 1 upon F. Fine. So F becomes minus X. So the value of X with negative sign will give you the focal length of concave lens that is going to use in myopia. Clear? Now to calculate power of the lens, we have formula power is equals to 1 upon F in meters. Clear? Or you can say it is 1 upon minus X in meters. Right? So by using this formula, we can find the value of focal length and the power of lens. Clear? Now let us discuss the case of hypermetropia. Again using the formula, lens formula, that is 1 by V minus 1 upon U is equals to 1 upon F. Fine. Now in the case of hypermetropia, the value of U is equals to minus 25 centimeter. Fine. That is the near point of normal eye. Fine. And the value of D, the value of V becomes, and the value of V is minus X. Fine. The value of, I'm repeating again, the value of U is minus 25 centimeter. That is the near point or least distance of distinct vision, and the value of V is minus X. That is the near point of the defected eye. Fine. Now putting these values, we have 1 upon minus X minus 1 upon minus 25 is equals to 1 upon F. So the formula becomes minus 1 upon X plus 1 upon 25 is equals to 1 upon F. Fine. From this formula we can calculate the value of focal length. Again using the formula P is equals to 1 upon F in meters, we can calculate the value of power of lens that is going to use in hypermetropia. Clear? Now let us solve one numerical that is based on myopia. Fine. Now the question is, the far point of myopic eye of a person is 2 meters. Fine. In front of the eye, what is the nature and power of lens required to correct this defect? Fine. We know that in the case of myopia, 1 by V minus 1 upon U is equals to 1 upon F. Fine. The value of U is minus infinity. Fine. And the value of V, that is minus X, the value of X is 2 meters. So it becomes minus 2 meter. Fine. Now put this value in this equation. We have 1 upon minus 2 minus 1 upon minus infinity is equals to 1 upon F. So it becomes minus 1 upon 2 is equals to 1 upon f, because 1 upon infinity is 0. Fine. Reciprocal it, so it becomes f is equals to minus 2 meter. So the focal length of the lens is minus 2 meter. Fine. Now to calculate power of lens, that is 1 upon f in meters. Fine. The value of focal length is in meter. Fine. So you can use 1 upon f. The value of f is minus 2. So it becomes minus 1 upon 2, which is equals to minus 0.5 diopter. So the power of the lens is minus 0.5 diopter. Now look, the sign is negative. Fine. If the power of the lens is negative, this indicates the corrective lens that we are going to use in this numerical to correct the defect of human eye, that is concave lens. Fine, because the power of concave lens is negative. Clear? Now the next question is, the near point of a hypermetropic eye is 0.5 meters. Fine, means the value of V, means near point of hypermetropic eye is 0.5 meter, or you can say 50 centimeters. Fine. Find the power of lens required to correct this defect, given that the near point of normal eye is 0.25 meters, means the value of u, which is equals to minus d, which is minus 0.25 meter, which is equals to minus 25 centimeters. Clear? So the value of v is also negative. Fine. So v is minus 50 centimeter, the value of u is minus 25 centimeter. Using lens formula, 1 by v minus 1 upon u is equals to 1 upon f. Fine. The value of v is minus 50 minus the value of u is 1 upon minus 25 is equals to 1 upon f. Fine. So it becomes minus 1 by 50 plus 1 upon 25 is equals to 1 upon f. Fine. Or by taking LCM, 50 minus 1 plus 2 is equals to 1 upon f. Fine. So 1 upon f becomes 1 upon 50. Clear? So the value of f becomes 50 centimeters, which is equals to 0.5 meter. Fine. So the value of f is 0.5 meter. Clear? Now to calculate the power of lens, we have formula P is equals to 1 upon f in meters. Fine. So the value of f is 0.5. It becomes 1 upon 0.5, which is equals to plus 2 diopters. Fine. So the power of the lens required is plus 2 diopter. So this plus sign indicates the lens required is convex or converging lens. Fine. So by using these formulas, we can calculate the power of lens required to correct the defect of human eye. Clear? Thank you.